Okay, here we are again, my EOC number 10. So EOC journal number 10. Whoops, don't want to do that. And this one is going to be interpreting graphs. Okay, the one good thing about this one is there's not a whole lot of work involved with this. Basically, you have to be able to read a scenario and plug it into a graph or create the graph from the scenario. So, it's just going to take you some rationalization, and you have to read carefully. Take your time to do the best you can. All right, here we go. Let's get started. Henrietta left home and drove her car on a 300-mile trip to visit her grandmother. She traveled at a constant speed of 60 miles per hour. Which of these graphs best models the distance Henrietta was from home based on the time she had traveled? Okay? So, you have 4 different graphs, and again, this is one of those questions you're going to have to look at the graphs in order to get your answer before you can start. And so what we're looking at is Henrietta left her home and drove her car a 300-mile trip to visit her grandmother. She traveled at a constant speed of 60 miles per hour. Which of these graphs best best models the distance Henrietta was from home? From home. I mean, these are key words right here. From home, based on the time she had traveled. Okay, so you're talking about distance based on time. So if home, what does home equal here? In this scenario, home equals 0 miles. Because we're looking at the distance from home. So if we're at home, we're at 0 miles. If we go down, let's say we go down to the corner store and the corner store is 1 mile away, we would say now we are 1 mile from that. So we've increased our mileage to 1. And then if we go further, we've increased it to 2, 3, 4, 5, whatever. So that's what we're looking at here. Now, over time, as we drive 60 miles per hour, what's going to happen? Are our miles going to increase or decrease? Well, the miles are going to increase. Okay, so as we drive 60 miles per hour, our miles are increased, not decreased. So we can right now eliminate A and C because those are decreasing. So we start at 0, and after 1 hour, we're here. That looks about 50 miles per hour. It's hard to tell to be exact, okay? Because if these are in increments of 50, 0, 50, 100, 150, 200, 250, and 300. So this looks to be about 50. Well, so 1 mile, not 1 mile, 50 miles equals 1 hour. Well, how fast are you going there? 50 miles per hour. That's where you get that 50 miles per hour, because that's a rate. So you can go 50 miles in 1 hour, so that's 50 miles per hour. Now here, in this next graph, it looks almost the same, but it's just barely higher. And I actually missed it. There it is. It's just a bit higher than 50. And so that's where you're 60. And again, I don't know exactly because of the graph, but it looks about 60 miles per hour. So that's all you have to determine. B and D are very close together. And this is not a very good example of a question. It's tough, especially reproduced. On your tax test, you'll be able to see the lines a little bit better. On your STAR test, you'll be able to see the lines a little bit better. But you have to look at it like that. First, you have to determine what does home mean. Okay, well, home means 0 miles. You go to grandma's. Grandma's is at 300 miles. So grandma's, I'm going to put GMA, is equal to 300 miles. So you're going to go from 0 when you start, drive 60 miles per hour. So 0 when you start, 60 miles per hour, and then you're going to go 300 miles. So here's 0, here's 300, and you're driving 60 miles per hour, so your distance is increasing. Okay, you're just going to have to break it down like that. Please notice that even though there's not a lot of mathematical computation, you can see the work that's being taken place. All right, that's it for this one. Not too difficult. Hope you can understand that. If you have any questions, shoot me an email.